All right, welcome back. This is example 5 from 1 of day 23. So this is a continuation of the previous example, which was working with solving the system using the differentials notation. And so we were left off with this system with these four unknowns and these two equations. And so in example 5, we're given the initial conditions that x of 0 is equal to 1 and x dot of 0 is equal to 0 and y of 0 is equal to 0 and y dot of 0 is equal to 0. Okay, so now we have four initial conditions and we have four unknowns. So we're going to substitute each of these unknowns and each of these values into this system and create a system of equations and a system of unknowns. To do that, it will also be noteworthy to recognize that for each of the values, since we're plugging in 0 for sine, each of the corresponding sine values will be 0. And that'll be really nice to eliminate some of the confusion with respect to what values go where. Okay. Um, all right. Without any other further ados, let's go ahead and plug in. So for x of 0, so I'm going to put little numbers here. And these will indicate the rows of the matrix in the following um, system of equations. Okay, so for row 1, if I plug in x equals 0, I get 1 is equal to, that's kind of going backwards here, cosine of 0 is 1, so I get C1, that's 0. I get, that's going to be 1, so I get C3, and that's going to be 0. Okay. The derivative here is going to be equal to 0. So 2 is going to give us 0 equals. Let's see, the derivative that's cosine, so it's negative sine. So that's going to be 0. And then that's going to be cosine, so that's going to give us a C2. And then what else are we going to get? We're going to get, this is a cosine. Derivative of that's going to be a sine, so that's going to give us a 0. And then derivative of this sine is going to be the square root of 5. Cosine, and that's going to be gives us a 1, so this is going to be square root of 5 c times c4. That's that one. All right, 3. We're going to get 0 here. Okay, going here, we're going to get a c1. That's going to be 0. Going to get a negative c3. And then, of course, c4 will also be 0. Because the sign is 0. Okay. And then 4. We're going to get another 0. And let's see, what do we get? The derivative of cosine is a negative sine. That's going to be 0. Derivative of sine is cosine, so that's going to give us a C2. The derivative of cosine is going to be sine, and that's going to give us a 0 for C3. And the derivative of sine is a cosine, and so we're going to get a negative square root of 5C4. There. Okay. So we can write this as an augmented matrix and then solve for the system. So we're going to get 1, 0, 0, 0. That's our B vector. And then we're going to get 1, 0, 1, 0, 0, and 0 square root of 5, 1, 0, negative 1, 0, 0, 1, 0, negative square root of 5. C1, C2, C3, C4. All right. So we're going to go ahead and plug this into Maxima and solve for each of the unknowns. And then we'll use that to also plot the solution. So we're going to go ahead and jump over to that and get started with the next. All right. Now that we're back in the computer, we see we wrote in the matrix A here. So for for Maxima, you write the term matrix, and then you separate each row by these brackets, and then a comma separates the brackets for each row. So if we plug those in, we see our solution matrix X for our linear system. So A times X is equal to B. So to solve for B, we simply need to invert the matrix A and multiply it by a matrix or solution matrix B. Okay, so if we do that, let's go ahead and hit enter. And we get here, you can see that C1 is equal to a half, C2 is 0, C3 looks like it's a half, and C4 is equal to 0. Perfect. So then looking back at our solutions for the general equations, it looks like the C2 and C4 are the sine terms, and so they're 0. So now we can create a new function. So we'll call it x of t. That's going to equal, so C1 was a half. That's a half times cosine of t plus C3 is a half. Actually, I can probably just factor out that half of everything. So 1, 2 times cosine of t, that's the C1, plus cosine of the square root of 5 times t. That's the C3, factoring out the common factor of a half. Okay, and then let's do y of t, and that's going to equal, looks like the same thing. So uh, a half times cosine of t minus the cosine of the square root of 5 t. Okay, very similar, just off by a sign. Okay, so those are our two functions, and now we want to plot 2D and actually plot 2D. That way it stays in this frame. So we want x of t, y of t, and then we want t to go from, let's see, I guess we'll find out, 0 to 0 to, let's try like 3 or 4. Okay. All right, let's see how that looks in our plot. And so you can kind of see there, you can go out a little bit further and see how the two look over time. So kind of get a sense of how they're interacting and reconnecting with each other over time. All right, I hope that that was helpful, and I will see you in the next video.